Good morning, everyone. My name is Jessica, and I'm a final year PhD student at Harper Adams University. And I'm here today to talk to you a bit about some of my PhD research, which is looking at mycotoxins in grass silages. So, what are mycotoxins? Mycotoxins are compounds produced by fungi, and they can have immunosuppressive effects on animals and humans. And they can also, some of them have carcinogenic effects on animals and humans. And over 200 mycotoxins so far have been identified, but the mycotoxins to the left of the screen are currently the only mycotoxins that are regulated by the EU. And here's some ideas of, well, it's just some pictures of the devastation that mycotoxin contamination can have on the food industry. And it's estimated that 60 to 80% of the world's crops can be contaminated by mycotoxins, and 20% of those that are contaminated can be higher in contamination than the threshold guidelines set out by the EU. So, ruminant animals have generally thought to be less sensitive to mycotoxins, and that's due to the microorganisms inside their rumen microbiome. So inside the rumen microbiome, there are bacteria, archaea, fungi, and protozoa. And some studies have found that some of these microorganisms are actually able to break down these mycotoxins into less harmful metabolites, so they don't actually affect the health of the cow. However, not all mycotoxins are actually able to be degraded by the ruminant microorganisms. And the majority of the mycotoxins that have actually been looked at are mycotoxins that are commonly found in maize silages. Now, grass silages make up a large proportion of the diets that we feed to dairy cows in the UK and in other countries in Northern Europe. And they often do not contain the same mycotoxins as the tests that we've carried out have looked at. So, non-regulated mycotoxins that are in grass silages may still pose a risk to dairy cows in the UK. And a lot of the reasons, some of the reasons for that is the mycotoxins that have been identified in grass silages can have antibacterial properties. So it's thought that some of those antibacterial properties might actually disrupt the rumen microbiome, which could lead to a decrease in the dairy cow performance. Additionally, any other illnesses that cows are suffering at the time may actually hamper their ability to degrade mycotoxins that we've already shown they can degrade. So one study here by Debevere suggested that at levels of subacute ruminal acidosis in the rumen, the microorganisms were actually less able to degrade mycotoxins that they were shown to otherwise have been able to degrade. So before I did this PhD, I was very much in the just scrape it off and carry on eating it group. I think I probably would have left the one on the right, but just cutting off the crust and eating it. And I thought I would have been absolutely fine. And a lot of dairy farmers may think, oh, there's only a bit of mouldy silage there, I can see it. I'll just chuck that bit off and I'll feed the better bit to the cows. And unfortunately, looks can be pretty deceiving. So these are two clamps that I visited during my farm survey, which I'll discuss in a bit. And the clamp on the right, you can see, is a little bit of a car crash, unfortunately. It's extremely spoiled. There was even fungi growing. You could see it, fungal bodies growing in the silage. And then the one on the left is kind of a more typical dairy farm silage clamp that you would expect to see. Now, penicillic acid is a mycotoxin that is found in grass silages, and it has known antibacterial effects. So it's one of those mycotoxins that could actually impact on the performance of our dairy cow. And I'm here to show you that. In this silage here on the right, there was found to be 2,168 parts per billion of penicillic acid. And even though this one looks better, there was actually 10,500 parts per billion of penicillic acid in that silage. So looks are extremely deceiving. You can't just scrape off the top of the mould and feed the rest of the dairy cows. So what risk factors are actually involved in the contamination of mycotoxins in silage? So my main hypotheses were that grass silages are at higher risk of mycotoxin contamination with sward management and extreme weather conditions. So if your sward has experienced periods of drought or flooding, that may have an effect on the initial mycotoxin or fungal load coming into the silage. And an unsuccessful fermentation. So a fermentation that doesn't decrease the pH rapidly enough to allow for, to prevent Clostridia and other spoilage organisms growing, and also poor clamp management upon opening. So a clamp that allows for a lot of aerobic spoilage, because that would allow for the growth of fungi and yeasts. So these are my hypotheses when I set out to look at the clamps across Great Britain. So I carried out a farm survey where I visited 37 grass silage clamps that were all dairy farms across Great Britain, and I took samples for mycotoxin analysis, fermentation profile analysis of the silage, clamp measurements and observations, and I also asked farmers a load of really irritating questions about what they did last year regarding their clamp management and silage production, to see if I could associate any of these with the instance of mycotoxins in grass silages. So here's just a diagram of where I took samples. So I took 2 samples from the shoulders of the clamps, one from the top center and one from the middle. I bulked the top 3, so there was a top sample and a mid sample. And then there's just an example of some of the questions that I asked farmers here about their additives that they applied, sheeting practices, and whether there were multiple cuts or multiple crops in the same clamp. And then just some pictures to show you the wide range. The majority of the clamps were pretty standard looking, although I've just put out some extremes for you here. So unfortunately this one, you can see, experienced some slippage. On the left, you've got this one with quite an excessive amount of effluent produced at the bottom. Arguably, either the compaction or the management post opening is poorer for this silage. And then also we've got some visible mold actually on the silage there. So what did I see? The clamp face areas varied across the farms from 11.6 to 119 metres squared, so it was a good indicator that I'd captured quite a range of different size clamps, and potentially in that information a range of different herd sizes as well. And the clamp compaction density, the median values would indicate that across the board the majority of the clamps were relatively well compacted. However, there were a few outliers where the minimum compaction was pretty poor in the shoulders especially, which is not surprising, as there's quite a few clamps there where the shoulders are more difficult to actually get as well compact as the rest of the silage. And but overall they were pretty well compacted, and the difference in the temperatures between the 50 centimetre and 10 centimetre depth were taken at each silage core. So a higher temperature at a 10 centimetre depth compared to a 50 centimetre depth would indicate that there is clamp heating going on at the face of the clamp, and that would be an indicator of whether aerobic spoilage was happening or not, and that would be due to the yeast activity. So overall, the median values for the difference in temperature suggested that there was actually very little aerobic spoilage going on, apart from a couple maximums here in the top left and top right shoulder again, which kind of tie in nicely with that poorer compaction in the shoulders that I did see for another one of the farms. So all in all, in terms of the dimensions, I captured quite a nice range of different types of clamps across Great Britain. And then looking at the fermentation profile, again, the dry matters range from 219 to 489 grams per kilogram. So that was a nice range of clamps, again, just suggesting that I captured that breadth. And also there was quite a low level, quite low median level of butyric acid, suggesting that across the board there was quite low evidence of clostridial fermentation, which would suggest that clamps were pretty well fermented. And the lactic acid to acetic acid ratios, again, went from 0.334 to 15, which would suggest that over the clamps that I sampled, there was a vast range of clamps of silage that had experienced either homo or heterofermentative fermentations. So the mycotoxin profile of the clamps, there were actually some regulated mycotoxins that appeared in the clamps. So deoxynivalenol, zearalenone, and then the fumonisins in the middle are actually regulated by the EU. But as is seen in grass silages, they were at pretty low levels in comparison to what the EU recommends. So though there were regulated ones there, they weren't really that much of concern. And there was the presence of fusaric acid and penicillic acid, which I want to draw your attention to, because they were present in over 70% of the samples, both of those mycotoxins. And penicillic acid, as shown previously, was at the maximum one of those samples at 10,500 parts per billion. So though we don't necessarily know the effects of those mycotoxins on the microbiome especially, we do know that they do have antibacterial properties, and so they could be a cause for concern with regards to animal performance. And then the last thing here I just want to draw your attention to is the Alltech risk equivalent quantity. So this is just a measure of overall mycotoxin risk. So obviously there's quite a few mycotoxins on there, and they all have different activities, and it can be quite difficult to assign how severe one is to the other. So the Alltech risk equivalent quantity gives you an overall measure of how detrimental those would be to dairy cows. So what are the relationships? So I actually found a negative correlation with dry matter and mycotoxin risk. So silages with a lower dry matter were a higher risk of mycotoxin contamination. And silages with an increased lactic acid concentration were at a higher risk for mycotoxin contamination. And interestingly, silages with a higher acetic acid concentration were also at a higher risk of mycotoxin contamination. And so were silages that had a higher ethanol concentration. So in summary, a higher lactic acid, acetic acid, ethanol, and a lower dry matter concentration were associated with an increased risk of Aspergillus, Penicillium, and Fusarium mycotoxins, which to some of you might seem quite odd, because those of you that use heterofermentative additives will use them to increase the aerobic stability of your silage. So heterofermentative bacteria will produce acetic acid and ethanol, and they're known to have antifungal effects. So we know that adding heterofermentative additives actually decreases the growth of fungi, but my research has shown that the products that they actually produce during that fermentation may decrease the fungal growth, but actually increase the risk of mycotoxins. And then to tie it off, I'd just like to speak a little bit on the questionnaire. So I asked farmers roughly over about 30 questions about their silage management. And I just wanted to pick out these three, which I thought had interesting associations with the mycotoxins that were found in the silages. So that is of drought stress, sward type, and whether the weights were in use on the clamp or not. So the first one that I want to go through is penicillium-associated mycotoxins were higher in silage that had been made from drought-stressed swards, and they were also, Aspergillus was also higher in silages that had been made from drought-stressed swards. In clamps that had been in silage that had been made from grass-only swards, the incidence of mycotoxins were higher than those that had been made from mixed swards, such as multi-species sward or herbal lays. And in terms of the top weight use, so this was any top weights present at the time of visit. I did have a few cheeky farmers that said, oh yeah, I used top weights, and then I got to the clamp and there was nothing on there, or the sheet had come off. So I wrote down whether it was present at the time of visit, and I found that when no top weights were in use, there was an increased risk of Aspergillus-associated mycotoxins and Penicillium-associated mycotoxins. Now, I can't comment exactly on why there's this association or relationship, but I did find that the silage that had been drought-stressed and the silage of the grass-only swards did have a lower dry matter, and the lower dry matter is associated with an increased risk of mycotoxins. Additionally, the silage that had no top weights in use also had a lower dry matter, and again, that could have been associated with why they had a higher risk of these mycotoxins. Or it could just be to do with management, but I think further work needs to investigate those reasons. So in summary, there was a range of non-EU regulated mycotoxins found in grass silages. Penicillic acid and fusaric acid were the most common silage mycotoxins found, and legislated mycotoxins were found in grass silage, but at low levels. So it's those non-regulated mycotoxins that really need investigating because of their potential to reduce animal performance. Positive relationships were found between lactic acid, acetic acid, and ethanol concentration and the overall risk of mycotoxins, which is interesting because we know that acetic acid and ethanol are generally thought to be antifungal compounds. but it does not necessarily mean that the mycotoxin risk is reduced. And it kind of links back to that picture I showed you, where just because there's mold present doesn't necessarily mean that there is a higher incidence of mycotoxins. And equally, just because there's less mold present does not necessarily mean that there isn't a really high concentration of mycotoxins. And then my last point that I think all of you should take away today is that just because a silage looks good in life and on paper does not mean it's mycotoxin free. Now, I'm afraid my title is risk factors and remedies. I don't necessarily have that many remedies for you. Potentially, make sure you've got top weights on your sheets. And also, just keep an eye on your performance of your cows. If you're starting to see performance dropping and you can't actually find a reason as to why that might be, it might be time to think about getting your silage checked out for mycotoxin contamination, especially if it is a silage of low dry matter and you potentially used a potentially high lactic and acetic acid fermentation. Thank you very much for listening. I'd just like to thank everybody on the mycotoxin research team at Harper Adams University, my sponsors Alltech, and also a big thank you to Dr. Dave Davies of Silage Solutions. And thank you to Harper Adams University and MIBTP for sponsoring my PhD. And I'll be happy to take any questions.
Hi, Kaylee,
Hello.
dairy farmer. Could mycotoxins be linked with triggering a false positive in antibiotics in a milk sampling?
Yeah, it's a really good question. I've heard anecdotally that there has been a case of a farm where their antibiotic test came back positive, and they coincidentally had a high instant of penicillic acid mycotoxin in the silage. But it was very much coincidental, and I think it was probably down to other management factors. Because we don't know that much about grass silage mycotoxins, we don't know what the exact effect of those mycotoxins could be when they enter the cow. We don't know if it's necessarily exposure to the milk just exposed to penicillic acid that could be around the farm, or whether it's actually coming through the cow itself into the milk. We just don't know, unfortunately, because we've not actually studied it. There's not enough literature out there to know, really. I mean, penicillic acid is related to penicillin, which is an antibiotic, obviously, but it is less extreme than penicillin, so it's not as strong as penicillin. So it would depend very much on how they actually do the antibiotic testing, because if they're also searching for a particular antibiotic in that, then they may not pick up on others. Or if they are looking at antibiotics in general and just any antibiotic interaction, then penicillic acid could come up as an antibiotic. So we don't know enough yet, and we're not sure on how penicillic acid would show up in the tests, basically. I hope that kind of answers your question, sorry.
Chris, just a farm vet from the southwest. Drought-stressed grass was one of the big variables, if you like. Within that subset, are there any covariables that explain lower levels of mycotoxins despite a drought-stressed grass, what the farmer could do?
Sorry, explain a bit more.
If you've got a drought-stressed grass in
Yeah.
your data set, could you see other variables on the farm that despite drought-stressed grass, in the drought-stressed grass data, that they could reduce mycotoxin risk significantly?
Not necessarily. I think the drought stress also probably needs looking further into, because it was difficult to actually know whether that crop had experienced drought stress at what period of growth. So we didn't actually ask the farmers of what period of growth it was actually during. It could have also been ensiled in a clamp with other silages that may not have experienced drought stress. So that data needs looking into a little bit more, and a few more questions could be asked regarding that. I think the other difficulty is that sort of saying to farmers, oh, did the crop experience drought stress? To what extent did it actually experience drought stress? They could have said, oh, it was a really warm summer or whatever, but it might not have necessarily been that. The crop might not have necessarily experienced a period that stress as much as another crop, for example. So I collected quite a lot of data regarding this questionnaire, but I think a lot of the questions, unfortunately, were a bit too subjective to include in analysis. So that's why I've picked out just a couple to have a look at. Thank you very much.